Hello everyone, my name is Fabrian, who will be presenting our work about white matter hyperintensities evolution prediction using probabilistic deep learning with adversarial training and volume interval estimation. This work is a collaboration between Brain Image Analysis Unit, RICAN CPS, and Center for Clinical Brain Sciences, University of Edinburgh. The study mainly focuses on white matter hyperintensities or WMH. WMH are neuroradiological features seen in T2-FLAIR MRI, characteristic of small vessel disease or SVD and associated with stroke and dementia progression. As seen in these two figures below, clinical studies have indicated that WMH on a patient, both in volume and spatial location, may decrease, stay the same, or increase over time. To represent spatial changes of WMH, our previous studies have proposed the use of Disease Evolution Map or DEM, which shows growing, shrinking, and stable WMH like this image. From our previous studies, we noticed that the growing and shrinking WMH are usually located in similar areas. This is more clearly seen by separating the prediction channels of WMH like these images. For example, by combining non-WMH channel with growing WMH channel, we can get this prediction image of most probable areas where WMH will grow in the future. Similarly, if we do the same procedure for the shrinking WMH, we can get similar prediction image like this, but for a shrinking WMH. From these two images, we can see that some areas of the brain have similarly high chances for WMH to be growing and shrinking. From this observation, we argue that predicting disease progression always involves a high degree of uncertainty. From our previous studies, we have identified two uncertainties, which are spatial uncertainty and volume estimation uncertainty. Thus, in this study, we proposed of using probabilistic unit with adversarial training for capturing the spatial uncertainties and a novel evaluation procedure named volume interval estimation or VIE for better interpretation and higher confidence in the estimation of feature volumes of WMH. Probabilistic unit is variation of unit where a set of variances is sampled from a latent space, which is learned from a posterior information and concatenated to the unit's feature maps before segmentation layer. Furthermore, in this study, we also added a discriminator network to differentiate between real and fake prediction of DEM. After the training, probabilistic unit uses prior information, which is T2-FLAIR baseline scan or T0, to get some variations of prediction. Note that most information used for predicting WMH evolution in spatial space still comes from the unit. In this study, brain MRI scans from untreated 152 stroke patients acquired by using a GE 1.5T scanner are used for training and testing using four-fold cross-validation. T2-FLAIR baseline scan and one-year follow-up scan are used for T0 and T1 data respectively. These are quantitative results comparing performance of unit and probabilistic unit for predicting spatial and volumetric changes of WMH in D-score and error and MSE respectively. We can see that by using follow-up T2-FLAIR data and DEM as posterior input data, we can get better prediction of dynamic changes of WMH, especially in spatial space. We also can see that using focal loss function from the retina net outperform the weighted cross entropy loss. Next is quantitative results of using Gun's discriminator and adversarial training. Firstly, we can see that adding Gun's discriminator and adversarial training to the unit successfully improved the results. Furthermore, they also improved the results of probabilistic unit in some settings. Based on our observation, adversarial training successfully removed small false positive clusters in the prediction results, shown by the red arrows. Another contribution of the study is the volume interval estimation or VIE. We argue that it is better to predict future volume of WMH in interval, where not only we have a point estimation of future volume of WMH, but also estimated minimum and maximum volume of WMH. We can do this by dropping prediction channels of growing WMH to get minimum volume estimation, and dropping prediction channels of shrinking WMH to get maximum volume estimation. VIE also provides us categorization of prediction for each patient. For example, the blue highlight covers all patients that are correctly predicted. Green highlight covers patients that are not only correctly predicted, but also within the interval, while the orange one covers all patients of which their future WMH volumes are estimated within the interval. In conclusion, probability unit produce better prediction of WMH evolution given useful posterior information. Adversarial training help by removing small clusters of false positives, and the VIE provides us with richer interpretation of the results. Future works including incorporation of VIE into the prediction model as a cost function. Thank you very much for listening. These are our sponsors.